Well guys, I have a ton of work to do today because I have to pull the engine and completely tear it down to get it ready to be built into an 1100 horsepower monster. And I'm not talking about the AMG. The AMG is running great and I'm having a blast driving it. But I do need to build an engine and it's not for me. It's actually an S54 turbo nitrous engine for my old pro drift car, my E46, which is now owned by my good friend Dimitri Brutsky, and he needs a new engine for the 2025 Formula Drift season. I figured, you know what, if I'm gonna be building this engine, I've only got 2 weeks to do it, but I might as well film it too so I can show you guys the start to finish of what I do to build a 3.2 liter straight six into a 1,000+ horsepower capable engine that has been really reliable for us in the past seasons. I've run one of these engines for 3 seasons in a row, just doing oil changes and spark plugs. So they've proven to be really reliable when built correctly. And I figured, you know what, show you guys how to do it. Well, obviously, to build an engine, you're gonna need a donor engine. And that is what I have behind me right here. This is an E46 sedan that I had been building into a practice car when I was still running in FD. And then, well, decided to leave. And this car never got finished because I didn't need another car. I had a few cars that were already running that I could take to the track whenever I wanted to, and this just sat. So before I sell this chassis, I'm going to pull the S54 out of it and use this as the donor engine. So let me get started on that right now. We got pretty much everything disconnected. It's almost ready to come out, just the motor mount bolts that are holding it in place now. And luckily my buddy Stan, who used to work for me, he just showed up, so he's gonna help me pull this thing out of the car. What's up, Stan?
What's up, guys? How you guys doing?
Stan bro.
Stan bro, live in the flesh, huh?
It was perfect timing. So Stan came by to pick up a couple go-karts and we just loaded them up in his truck. And now it's time to yank this S54 out of here. Let's get to it. All right, engine is out and we got the engine on the stand after we pulled the transmission and clutch and flywheel and all that stuff out. Next step is to remove all of the accessories, everything on the outside of the engine, the alternator, all obviously the belts, the intake manifold, the headers. And once I get all that stuff removed, then it'll just be the bare long block and I can start tearing into that. All right, well now I've got all of the accessories off of the engine and just pulled the throttle bodies off. So the S54 actually has individual throttle bodies from the factory, and just behind those throttle bodies is probably visually one of the most impressive parts on the S54 engine from the factory, and that is a CNC ported head, at least on the intake side. It's pretty impressive looking. It's like a razor sharp center. And well, there are not many cars that come with a CNC ported head from the factory, but that's how BMW was able to make 333 horsepower to the flywheel out of a 3.2 liter engine back in 2001. Maybe even 2000 is when the first E46 came out with the M3 engine. So pretty impressive stuff. All right, next step is to pull the rest of the accessories off, kind of accessories, but now it's the oil filter housing, the water pump housing. Those things are going to come off, and actually it's not the water pump housing, it's the thermostat housing. The water pump actually just bolts directly onto the block, but that's got to come off too. And then I can pull the valve cover and then pull the head off, pull the oil pan off, pull the crank, rods, pistons, all that stuff will come out pretty shortly. Also, you guys might be seeing that the engine is dirty. If I was pulling stuff apart to just say change the throttle bodies or change the valve cover gasket or something like that, I'd spend a lot of time cleaning the area around it, making sure that no debris would fall into the engine while those parts were off. But since I'm completely tearing this engine down, it's gonna go to the machine shop, it's gonna get cleaned, and then it's gonna get machined and then cleaned again. So if I wasn't gonna do all that, then obviously I'd take more time to make sure that no debris would get in the engine, but it doesn't really matter here. And everything on my end is gonna go into the ultrasonic cleaner. So I will put it through the ultrasonic cleaner multiple times if needed, completely disassembled so that everything is spotless. Well, I got everything off, including the valve cover now, so I can start pulling the Vanos off, pulling the cams out of it, and then removing the head. But before I do that, I want to show you guys what the inside of an engine looks like that has been run for a lot of miles in between oil changes, probably for a long period of time, like oil change intervals at 10 or 15,000 miles. It looks really terrible inside the engine. Let me show you that now. Just like sooty nasty burnt oil in this thing. All of that's going to get cleaned up though in the ultrasonic cleaner. So I pulled the timing chain tensioner out of here. This is basically an oil pressure hydraulic tensioner. So as it built up oil pressure, this plunger pushes harder against the timing chain rail and it keeps these from being loose. But now it is off there, it's loosened up. We also have another bolt that's on this side of the head that holds the chain rail that comes around here in place on the top. We've got that out. We've got all the bolts out to be able to take the Vanos off. And all that's left now is the two connections between the Vanos section and the cams. And that's a 10mm wrench and a 7mm wrench, and it's an opposite thread. So we're gonna back this out a little bit and then remove those two. They're just threaded in about probably 6mm of depth, so we'll unscrew those and then this whole unit will come off the front. Oh, there we go. So we've got the Vanos unit away from the cams and away from the head now, and we just have this joint that's right here. There's a flat on one side for a 7, and then there's this basically nut right here for a 10mm wrench to go on. Reverse thread, so I'll back those out on both sides carefully, and then when I get close to the end, I'm gonna have to actually hold this in place so it doesn't fall off, because those plungers are literally the only things holding it in place right now. You can put a long bolt in here so it has some support, but for me, I've done this so many times that that's not really necessary. I know when it's gonna come off and I haven't damaged one yet, so instead of going and finding other bolts to put in there to hold it in place, I'll just pull it off. But if you are doing this at home and it's your first time, definitely throw a couple long bolts in there so that the Vanos is supporting itself somewhat and it doesn't fall when it gets close to the end threads. You could damage that Vanos plunger, which is where that bolt basically connects inside the plunger, so you don't want to do that. That has been removed and it looks extra crusty. So some failure points in the S54 engine are actually the drive teeth that go from the cam sprocket into the Vanos oil pump. So it has regular oil pressure from the oil pump in the engine, and then it pumps it up to the Vanos, and the Vanos oil pump creates a really high pressure oil circuit just in the Vanos. I don't remember what it is exactly, but I think it's over 1,000 pounds. It might be 1,500 pounds. Don't quote me on that. I don't remember the exact pressure, but that's what controls the plungers moving in and out inside of the Vanos unit. And I will show you the gears here. So this is a spline gear that gets pulled and pushed, and that causes the cam to twist independently of where the timing chain is. So both sides have that, so you can control where the cam sits, at what point in the RPM range, in the throttle position, how much load is on the engine. You can control that with your ECU, and I think that's one of the best parts of this engine is the Vanos. When you take the Vanos away, you almost turn it into a 2J. So on a 2J, you've got just two cam sprockets, no adjustability unless it's the VVTi version, and then it has the exhaust or the intake, I don't remember. One cam has control, which allows you to get quite a bit more drivability out of the car, really brings up the power in the lower RPM and in the mid-range, and that's the same thing that the Vanos is doing. You are using the cam in its optimal position for the power band to basically pick up that power band in the lower RPM and in the mid-range. Instead of just making peak power, you can optimize the power all the way through the power band. So a lot of guys will remove it saying it's too complex. I think that unless it's a road race car that you are running only between like 6,000 RPM and 9,000 RPM, you don't need the Vanos. But in a drift car, I think it makes a huge difference. And anybody who's driven a car with Vanos compared to a car without Vanos will know what I'm talking about. We picked up so much power by just tuning the Vanos and looking at other people's dyno graphs where they don't have a Vanos. The mid-range and the bottom end is really poor. A lot of times they'll run nitrous, or you have to worry about the gearing a lot more, because if you're down in the revs, the car just does not make power. Well, I got the sprockets off and noticed that there was another issue. This timing chain, the bottom always breaks off. It's actually overlapping with the other part of the chain guide over there, and the bottom section just breaks off of it. So if you have a rattly S54, that a lot of times is the issue. It's held by this, it's pushing on the back, and it's kind of in a weird pivot point, and then it causes this to break. And there are aftermarket ones that are made out of a stronger material that solve that issue. But honestly, these things last for a long time, even the original ones. So if you're rebuilding an engine, you can upgrade them, or you can even just put a stock one in and they'll last over 100,000 miles. All right, now the cams are out. So next step, I'm actually gonna pull all of the rockers out of here. And if I was just pulling the head to change a head gasket or something like that, I would not be pulling out the rockers and everything. But since this head is going to get an entirely new valve train, new SuperTech valves, shims, springs, retainers, all that stuff is going to be replaced. So I'm going to pull the rocker arms out of the way. That way I can also clean everything. Obviously this thing is beyond filthy inside the engine. But looking at where the cams ride, basically the cam journals, there are no bearings there. It rides directly on the aluminum. Cams spin at half the speed of the engine. If this engine's at 9,000 RPM, those cams are only spinning at 4,500 RPM. There's a lot less load on them. It's not like they're connected to rods, connected to pistons that are taking all of that force. So the cams do have some force, obviously, as they lift the rockers and push the valves open, but it's very minimal. So they're capable of riding on that surface directly on the head. But that being said, if there's debris that goes through the engine, then into the oil goes the debris, and it goes through all of those passages and into the journals, and it'll destroy the head. And then, well, you got to buy a new head. It's not an easy thing to replace. You'd probably have to weld each one of those up and then bore them with a line boring tool, make sure they're perfect, and that's just too much work usually for most engines. If it's something super rare and you have to do the repair, then it is doable. But in this case, an S54 head is probably $1,000 to $2,000 depending on the condition. So definitely buy a new one. Luckily, this one looks okay, and so do all of the cam caps. These are numbered individually. It is so dirty right now, you can't see it, but under here there is a marking to say which position it goes in, because they're all put together on the head, line board, and they have to go back into that location. If you put it in another spot, it's going to be a little bit off, and at best case, you're just going to have a little bit of wear. Worst case, you're going to spin that journal and you could actually snap a crankshaft, or sorry, snap a cam shaft, depending. These are cast iron These are cast iron camshafts, and they will snap. So it might have, might be at the back of the head, and that one seizes, and then it snaps, and then those valves will never open again. You'll have a bunch of noise and a lot of issues. Well, it looks like I'm not going to remove the rockers and the rocker shafts right now after all, because that old burned oil is actually left like a thick sooty layer on top of the rocker shaft, and it will not come out. And I don't want to force it out because I don't want to do any damage to any of the rockers or to the head. So I'm going to let the guys at D-Sport run it through their parts washer cleaner, and then once that soot is loosened up, then they should slide right out. So instead of trying to force it out right now, I'm gonna leave it as is. I can still pull the head off, and that's what I'm gonna do next. So now that the cams are out of the way, we have basically just some head bolts to pull out, and then I'll be able to lift the head off of the block. All right, the head is off, and it actually looks, well, beside it being super crusty, the bores of the cylinders look really good, which is perfect because I don't care about the pistons, I don't care about the rods, but the block, I want to make sure that's in good shape. We are going to bore it out 1/4 of a millimeter over to make sure we get a really, really clean cylinder that's honed correctly for the new pistons and for the new rings to seat properly. So any little scratches that it has right now are going to be removed by that 1/4 millimeter of overbore. Everything looks, like I said, real crusty. Tons of buildup on the pistons. That's all just carbon buildup. At the cylinders are looking pretty good, and same with the head. The head looks crusty. Valves are a bit crusty, but the surface of the head looks really good. The head gasket looked all right. So this is a really good candidate for a donor engine for a race build. It had a lot of miles on it, it looks like, and a lot of lack of maintenance basically, but we're going to change all of that stuff. We're going to polish out the crank, so everything, all those surfaces are going to be brand new. We'll deck the head and we'll deck the block, and this is going to be a really, really solid engine. Everything is off the engine now except for the crank, the pistons, and the rod. So the next step is to remove the pistons and the rods. I'm going to take the caps off the connecting rods, and that'll allow the pistons to just slide out of the bore. If I was doing this and I was going to reuse the pistons or the rings, I would be very careful about any carbon buildup in the cylinder where the pistons actually slide out past the head, so the pistons don't come all the way up to the top of the cylinder bore, or maybe flat, but then the rings are down, I don't know, 5 or 8 millimeters or so, maybe 10 millimeters on some engines, but there's that little section on the top where the rings never ride and you get carbon buildup around there. So if I'm pushing that piston and rod down through there, you're going to get that carbon kind of hang up, and then you could damage the rings. Possibility of damaging the pistons too, but in this case they're going directly into the trash, and I do not care. The engine block, like I said, is going to get bored and honed, so no issues there. I'm going to pop all these caps off and just pop these pistons and rods out of the bottom, chuck them in the trash, and then we will take the crankshaft out after that. All right, that is all disassembled. The last step after I took the crank out was take out the piston squirters, which are they bolt on right here, and they spray oil directly onto the bottom of the piston, which helps lubricate the cylinders. It cools the piston, it lubricates the piston pin, keeps everything happy. So got those out of the way. Those will also get ultrasonic cleaned. But for now, I'm gonna load the block up. I'm gonna load up the head, the crank, and head over to D-Sport, have a talk with those guys and discuss this project with them. They already know that I'm bringing this stuff over to them, but it needs to happen pretty fast, and luckily they're going to do me a solid on this one and get it done. Like I said, only have 2 weeks to get this all done, finished, put onto a pallet, and get it shipped out to Dimitri, who's on the East Coast. So time is of the essence. All right, over here at D-Sport, and it's kind of crazy because they were supposed to be moved out a while ago. They're still looking for another shop. There's a lot of movement going on. I was going to pull into the driveway, but there was moving trucks and forklifts and all types of stuff going on. So we're actually just walking the cart out to the truck, which is down the street. And yeah, we'll go check out and see what's going on inside of D-Sport and all of the equipment that they have to move. Man, I feel for them. I've just moved, obviously, a few times, and it is not fun. And I didn't even move any big equipment. They have some massive, massive equipment that's gonna have to get moved. So I do not envy them. All right, so head, we're gonna get that up on the bench, and then we will dig through the box of SuperTech parts we just got. So full valve train, new intake valves, new exhaust valves, new springs, titanium retainers, guides, seals, all of it are, all that stuff's gonna be swapped out. So what do you think compared to, you guys do a ton of RB stuff?
Yeah, a ton of RBs, a decent number of JZs. Initial reaction is, you know, the RB probably has the largest bore spacing. So the amount of space between bores. In fact, between cylinder 3 and 4, they even add an extra 1.5 millimeters.
Oh, so this is spaced out even more than the other?
Yeah, it's really like
crazy.
2-3 cylinder engines. That's what I tell people. So what happens is a lot of machine shops mess up on this because they measure it. They're all, oh, these things are this far apart.
Yeah.
And they go and they bore it, and all of a sudden, but they get here and then it cracks right here because they didn't account for it correctly. And that's why it's like, oh yeah, it cracked right here. Well, because the guy probably did it wrong. So he just killed all of your wall thickness here, and then they cracked the block. Yeah. And that's pretty common, believe it or not.
Oh, that's not good.
But yeah, so what strikes me is you look at this, and the bore spacing is minimal. So this is a Siamese cylinder, meaning basically they're sharing this as their wall thickness.
Exactly.
And that's why they put these little steam ports in there. Otherwise you'd have like no way to get all this bubbling steam out of here, because this has got to be a super hot spot.
Yeah, you know? Yeah, it's basically, it's solid here, no cooling jacket in this part, and that's probably the end, right at the point of where the cooling jacket ends right there.
So to get that steam out of there, they use those steam ports. I mean, the finish from BMW on the machining, assuming this wasn't touched by anybody, which I don't think it was, is really nice. Actually, better than I'd say the Nissan and Toyota level of the finish that they put on it.
Yeah, I mean, I'm pretty sure this was 100% original, because looking, like, if you look inside the head here at how much carbon buildup and old, like, nasty burnt oil in there, it doesn't look like it had ever been apart.
Yeah.
And then also, like, peeling the head gasket off, it really felt like it was original. Stock head bolts and all that stuff. So yeah, I don't think it's ever been apart before.
Yeah, I've seen this before. A couple reasons. Could be like really long interval changes on the oil. They're just not changing it often enough. Other times people will use a racing oil that doesn't have a good detergent package in it, because racing oils, you know, they're switching them after each race and stuff, so they don't really expect them to stay in there. But they put a racing oil, they drive on the street, there's no detergent package, and all of this just keeps building up and building up over time. Yeah, these are a really, you know, nice head. I mean, I think you brought us one of these before.
Yeah, I brought you one that was damaged so you guys could cut it up and check, like, and really look into the ports and see what was possible and flow bench it and all that, because you were building one for somebody else. Yeah,
we found like there's basically nothing to really gain on the intake side. It's so nice. There's a little bit you can gain on the exhaust.
Yeah,
but even then, I mean, it's really a killer cylinder head, you know, especially after you get everything set right with the proper springs, the right rev limiter, you know, because it's both the mechanical and a electronic approach to get this thing from, you know, spitting out a shim and giving you issues.
Yeah,
you know?
exactly. That's where I had a ton of issues in the early days, and it took us a while to figure it out. We were also using a different ECU back then. We weren't using a Motec. We were using a Pectel, and we would always spit out exhaust shim cylinder number 2. Every single time we spit a shim, it was that one. And that's because of how the rev limiter actually cut. It would always hit hard on that cylinder and it would pop a shim. So we figured out that if we dropped the boost right before it hit the limiter and dropped the boost off, that would reduce the back pressure. We also put a very soft rev limiter in place rather than that really hard cut where you hear it like bop, bop, bop. We went to a really soft one where you could almost not even hear that it was on the limiter, and widened that range from 250 RPM to 500 RPM to where it was just real soft. You lost power and it kind of fell on its face, but not as bad as it would with a hard cut limiter. But that's what, in a combination with the SuperTech shim kit, because the shims that are in here right now are actually just little hockey pucks. They just sit on top and they basically rely on the retainer to keep them in place. But the new SuperTech stuff, it used like a bucket type shim where it kind of drops on top of the valve and keeps it from rocking around. So much less likely to pop off. That with a proper rev limiter really did the trick. Yeah, so here's just the little hockey puck kind of shim with nothing around it. And the other ones have a bucket that go in place. I don't know if there's any shims that are actually in here. I have the shim kit at the shop with all the different sizes lined up, so we'll dial that in. Another thing, I tried to pull the rockers out of here, but with all that buildup, I couldn't get the shafts to move more than like a 1/4 inch, and I don't want to force them through, so I figured
probably when we throw it in there, it'll get hot and it'll soften up. So
exactly, and then it'll loosen it and it'll come out.
So. And even if folks are doing it at home, you know, and they don't have access to that, you know, a pressure washer can help, you know, blow a lot of that stuff out. The other thing too, in trying to avoid, you know, spitting shims, a lot of times people, when they are doing the spring package, they're like, oh, I want to have the spring, you know, although my cams only lift 11 millimeters, I'm going to get the spring package that lets me have a max lift of 14 millimeters.
Yeah.
Okay, so then they have all this additional extra travel that they don't need. And when the valves float, guess how much extra they're going to float?
Yeah.
That much extra. So, you know, one of the other ways you can keep everything in check is by making sure you're setting up your valve springs and stuff right, so that when you're at peak lift, you can only go another maybe millimeter more, and that's it.
So you're almost looking for coil bind to happen at a little bit past the limit of the cam.
Yeah, that's one way you can limit it, and you know, you can, you got to be careful though, unless you're measuring every single one. You know, 40 thou or 1 millimeter is about, you know, a safe one. If you're measuring them each, you can cut it down to, you know, half of that.
Yeah.
But you have to measure each one individually, check your spring height, and go through.
Yeah.
If you really want to push it to the edge there, because you don't want coil bind either. You're gonna have other issues if that happens. So.
Yeah. There's so much science that goes into this, and development, R&D, and learning from other engines and just trying different things. It's building race cars that work to that like super fine tolerance is it's an art form, and that's what makes it really interesting. All right, Mike, thank you. We'll let you get back spec to it.
Yeah, definitely.
And yeah, you got another, what's that, another RB over there?
Another RB, yeah.
You guys are just cranking out RBs, huh?
It's all about the
RB
life.
specialist.
I know, I head over there. It's just madness because we're moving soon, so it's just like, ah.
Yeah, trying to get all
RB
these
pans.
projects done while you're still in this building, so you don't have to move a bunch of parts.
Yeah, we're trying to get all the machine work done before we have to move because we don't know if the machines are going to be offline for a month or something.
Yeah, exactly. I can only imagine, like, with all those machines, how they have to be set to make sure there's no twist in them, right? Because that affects. Dude, it's crazy. Yeah, there's so much that goes into it. It's
we'll spend a day on each machine setting it up, at least a day.
Yeah.
You know, just to get it. You know, then you got the time to run the electrical to it and everything else. So yeah, it's gonna be fun.
Yep.
Lots of fun.
Lots of fun.
My advice: don't lease your commercial buildings. Buy it.
Yeah.
So you can't be in California unless you're rich. So
That's right. Yeah. It's like,
Basically.
how are you gonna work on cars and be in California and not lease it? Like, you have to be rich.
yeah.
It's the only way it works. And then if you're rich, then why are you doing this in the first place?
Yeah.
I don't get it, but
You won't get rich doing
you won't get rich doing it. You might enjoy it, you might have fun, but you're not going to get rich doing it. All right, well, D-Sport has everything they need now to get this done, except for the pistons. The pistons are coming from 5150 Autosport. I just checked the tracking. They'll be here tomorrow, so I will take the pistons over to them tomorrow. I just wanted to get all the other stuff over there so they can start on the head. That's going to take a while. The machining of the block, they can probably get that done in 1 to 2 days, but the head, they've got to obviously clean it up, tear it down, pull all the old valves out, machine the seats, get the new valves and the new guides installed, new seals, all that stuff. That's going to take a little bit longer. So they have everything that they need minus the pistons. We'll get that over to them. And my job now is to start going through all of these parts, all the nuts and bolts and everything else, and getting them into the ultrasonic cleaner and cleaning them till there is nothing left. I want everything to be spotless, no debris, obviously. And right now, it looks like a bit of a mess over here. I've got all these parts just sitting up here on the shelf, piles of tools, and it is, well, it's a bit different than I would normally have done it, but since I moved out of this shop and I'm just back here for a few weeks, there is no organization at this moment in time. All my carts are gone, and my toolbox is all the way over there. Going back and forth between to grab parts and to grab tools has been a bit of a nightmare. But thankfully, I'm not going to be here for very long. Just need to get this engine done. And well, I'm not going to build the engine out here in the shop. I actually have my engine building room that is still there, and it's actually pretty clean. So that's where I will be assembling the engine. Entering the engine assembly room currently. Well, that is the engine that came out of Dimitri's car, and it is toast. See if we can see it down here. One of these pistons that are, oh, there it is, melted through. Destroyed obviously the piston, destroyed the block. This one also spun a thrust bearing, so the crank is damaged. It's not in good shape. The head also got damaged, so we are building a completely new engine to replace this one. But yeah, we'll be doing all of the assembly in here. We have temperature controlled and a very clean environment, nice workbenches to get everything laid out. I will move all of these things out of the way when it comes time to do the assembly, which hopefully will be in about a week. So I don't know if the next video on next Saturday is going to be the assembly. It's going to be a little bit tight. That might happen. If not, it'll be the week after that. But that's where you're going to get all of the details on what you need to do to check the rod bolt stretch, how to measure the piston rings, check the bearing clearances, torque the head down, check all the valve lash, do the timing, all the really detail-oriented stuff about building an engine. When I was tearing it down, I'm looking at everything and making sure I don't see any damage or any issues that could be a problem in the future. And then while I'm cleaning everything, I'll do the same thing. Inspect everything that I'm going to reuse. Luckily, I have boxes full of S54 parts, so if I do need another piece, I have those most likely already here. So we can, you know, pick and choose the best parts possible to build the best engine possible. So thank you guys for watching, and I hope you enjoyed this content, because not too far from now I'll be on my boat and I won't be building any engines that I know of. Hopefully I don't need to do any boat engines anytime soon. But that being said, thank you guys for watching, and we'll see you next Saturday, possibly with the completion of this engine build.